Now it is in the research. Earlier they were heavily involved in kitchen, and now they have taken the dual responsibility of kitchen as well as the education. So we highly salute them for their role in pharmacy profession and hope they will continue their potential role in educating the pharma students as well as for their research potential. So I'll continue with the lecture. So as explained, I remain as 6 years as director of School of Pharmacy and now a professor there. I am working on cyclopeptide synthesis. The goals and expectations of this presentation, I urge not to make any noise, just listen to the lecture so that you can get the maximum benefit. I am here for 1 hour. You can whisper later. So, goals and expectations, what you will be able to get. I have divided the slides like my last portion will be the literature survey on the peptide chemistry so that you can get the basic idea how a peptide research project can be developed on the basis of literature survey. And second part is the laboratory work. So how will you do work in the laboratory in the careful supervision of your supervisors for the peptide based project. So, in general, in pharmaceutical chemistry, we know what is peptide bond. When two amino acids club together, they form a peptide bond C1s through a covalent reaction with the release of water molecules. So, but the chemistry of this peptide do not stop here. It continues in the formation of tripeptide when 3 amino acids club together, as well as tetrapeptide when 4 amino acids club together. Pentapeptide, hexapeptide, heptapeptide, and so on. Here we want to stop according to design, but we go to the natural product. We can suppose our natural product is a cyclic heptapeptide, we can stop at the heptapeptide level and we can undergo the cyclization phase. I will show you a particular example how to go through that. Peptide, this peptide term is not coined by me, it is known since 1920s when insulin was first introduced into the clinic, and after that, up to 1984, there are several peptide synthetic derivative and natural ones came into practice. We know through the organic chemistry books the simple amino acid like glycine, proline, leucine, but here we deal with the modified amino acid like isoserine, chloroisoleucine. Here you can see the example of chloroisoleucine that is present in the cyclopeptide structure cyclolystin A, which is a natural cyclopeptide. And methylation is another important reaction which we can utilize in designing and modulating the biological properties of the existing peptide. We can N-methylate the peptide bond, so like that if suppose a heptapeptide is there, we can N-methylate the 6 bond and we can get 6 different derivatives through which we can develop the SAR and we can design our new product. Here is another example of N-methylation, 40 heptapeptide A which contains the N-methylated amino acid moiety which is N-methylated tyrosine. And here you can see the N-methylated proline unit. So every slide has below the published report. This actually in last 24 years I have synthesized about 70 to 75 cyclopeptides. And all slides are taken as an extract or conclusive remarks from the published paper. So if anybody is unable to understand the concept by the slide, which I am keeping here the copy, you can go to the respective publication and if any doubt is still there, you can email me so you will be comfortable with that. Even acidic moieties, ADP and AHPA are found part of the linear peptide structures like here we have shown a linear peptide from the marine bacterium where both of these can be you can see as part of the structure. Thiazole, oxazole normally we have studied as a individual moiety, but here those are part of cyclic ring. You can see the blue oxazoline and methyloxazoline moieties and in the red thiazole moiety petalamide structure which are naturally occurring cyclopeptides. In addition to these, normal natural heterocyclic amino acids are also present like histidine with the imidazole ring. tryptophan with the Indo ring. And in these five natural structure, you can identify these easily by means of red and blue arrow I have shown. You can study these publications to explore these further. This was an interesting slide which we took from our published report in marine drugs where we collaborated with the Wuhan University, China. And we found an interesting pattern of proline units present in the cyclopeptide structure was responsible for the bioefficacy. Like first three pattern or the 6-trans geometry in a particular fashion. So those who are interested to develop peptides on proline basis can go through this paper and study it well and they can design their new peptide-based cyclopeptide, which will be bioactive in terms of antimicrobial and anti-cancer. Other moieties seen are bromohydroxytryptophan and the tryptophan moiety. You can see in these structures, these are indicated by red and green arrows. Peptide structure can be linear or cyclic, but here you can see some of the example of linear structure. This is a mixture of cyclic and linear. Gramicidinous is a total cyclic structure and boroidin is a bicyclic structure. All are biological active. It depends upon your interest on which peptide chemistry side you want to go. These are abundant in marine sponges, marine mollusks. Here is one peptide from the marine sponge you citing. Other sources are cyanobacteria, hypomycetes, fungi, bacteria and plants. So one example from the plant INTK, it was synthesized in our laboratory. So cyclic peptide mainly they can be synthetic or natural. We can synthesize the identical molecules which are natural in origin and we can compare their efficacy. And even we can introduce certain segments from the established peptide antibiotic which may have the synergistic bio effect on your newly designed peptide. They are mainly concerned with the cytotoxicity. Here are some examples of our synthesized molecules. You can even resynthesize these molecules with certain modifications. You can introduce some other peptide moiety depending upon literature survey, and likewise you can design your new molecules in development of structural activity. Another activity is anti-HIV activity, which is where indolecidin and calipectin are involved, and cyclolyl peptides are concerned with the immunosuppressive activity. Similarly, hymenamides and halolitonin A are inhibiting the candida and cryptococcus species and show the antifungal effect. Salicylate and stylizumide are involved with the anti-dermatotic activity. Valgacyclamides are associated with the anti-malarial activity. Salicin and germinal are associated with the antibacterial activity. And mahapacycline and prodocycline A are involved with the anti-enzymatic activity. These all compounds I have synthesized over the last 20 to 24 years. But it does not mean I have synthesized, you can't carry out the work there. You can put the structure on paper, do proper literature survey, go for a bioactive segment identification at that particular segment in the diet or tripeptide form. You can insert a gene structure to design the new like prodocycline B analog. And you can compare with the natural and the synthetic compound, the bioefficacy, and you can develop the SAR. These are some of the other activities which are where cyclopeptides are involved. They act as cytotoxic by induction of apoptosis and proliferation reports that is a program cell death, and here inhibition of PGP and MRP1 is seen. Like in antifungal action, you can see the inhibition of cell wall biosynthesis and antibacterial. There will be interference with the cytoplasmic membrane barrier. And show some slide for mechanism of action of antibacterial action. So here it is one of the possible mechanisms for antibacterial action of cyclic peptide, where they bind with LPS, dearrangement of cell membrane happens with the increasing permeability of cell envelope, and finally leakage of cell death happens, cell content happens with the cell death. So likewise they can act as antibacterial. One another possible mechanism is they form a complex with pectoquinone There is interference with the dephosphorylation and strength formation of bacterial cell wall happens. This is another possible mode how cyclopeptide can penetrate bacteria. This slide I taken during the COVID condition where they target the viral protein receptor binding domain and were shown to have the antiviral effect. If you compare these molecules with the small synthetic molecules, say paracetamol, for paracetamol, for what purpose we are using? For reducing fever, paracetamol tablet. But if we are reducing fever by taking paracetamol tablet, you know it is inducing another condition called gastric toxicity in our body. It is a side effect associated with all non-steroidal anti-inflammatory agents. We can believe on peptides, they are biodegradable, biocompatible molecules. Peptide hormones are already present in our body. When they dissociate into amino acids which are not toxic. So these are some of the parameters we can utilize on selecting peptide-based research. If we compare cyclic and linear, always cyclic are preferred. In linear, we have the terminal, open terminal, which can go for more confirmation and which can lead to undesirable side effects. Everybody of you have heard, if I give you a bunch of keys and I'll ask you open a single lock, you will try each key, it will waste time. If I give you one key and one lock, you will easily go and open. Same thing happens when a drug enters in our body, it has certain functional group. And those certain functional group must be in proper orientation. Inside body receptors are there, it go inside the body and attach to those receptors in a particular fashion and a bioresponse comes. If those functional groups are not properly aligned and their stereochemistry is not proper, it can attach to other sites and it can lead to undesirable side effects as well as your bioresponse may reduce. So that is the base how cyclopeptides should be preferred over the linear peptides. Some other parameters I have shown. So if you see the literature, one new cyclic peptide drug enters the market every year on an average. Pharmaceutical companies are doing a lot of research on the cyclopeptide. And 40 cyclic peptide drugs are currently in clinical. There may be more, it may be the old slide. Here are some of the drugs I have shown which are with FDA approval and are peptide, cyclopeptide in nature and have the antimicrobial potential. Similarly, here I have shown the example of Vivatic, which is under clinical trial and a peptide-based drug. Here are other examples developed by different companies which are peptide-based drugs and are implemented in different disease conditions like diabetes 2, growth disorder, HIV, pain, etc. Here are examples of some of the drugs like bacitracin as a bacitracin cream, polymyxin B as IV injection, grabicillin S as a topical cream, vancomycin as a oral and IV, which are available in clinics, normally prescribed by a doctor. But we are not habitual about these terms. We normally see paracetamol, brufen, or likewise. But these exist in clinics. If we see the US peptide therapeutic market size from 2014 to 25, how it is increasing in USD billion, which again give you proof that peptide-based research should be encouraged in comparison to small synthetic molecules. If you see global peptide therapeutic market and clinical pipeline inside 2026, there is opportunity of $65 billion for global peptide therapeutic market. Out of these 65 billion, 22 billion claims only for the cancer peptide therapeutic. And that indicates how I showed in the literature survey they are mostly cytotoxic. And it is not necessarily they may not be cyclic peptide, but they may have peptide bonds in their structures. If you go through the literature survey, you will find such type of molecules. Okay, this was literature survey, what is available in the books, but US market says why we should be inclined toward peptide research. Now, if we agree with that we will do the peptide research, then what we have to do in the laboratory? That is another question. So before going in the laboratory, you must go for a close SWOT analysis. What are strengths of your project? What is weakness? What are opportunities and what are the threats? in the careful supervision of your supervisor and co-supervisor and any collaborator you have. Because you will start the course, this project on a degree base. You will be assigned a degree, like M.Pharm degree will be awarded, or B.Pharm degree awarded on the basis of the research project. So you have to take care of your timeline, whether you take care of certain factors, whether chemicals are available in your laboratory facilities are proper in your college, or you have to collaborate with some other labs where you will do the biological activity, where you will do the analytical study, and so on. That should be planned 6 months in before, otherwise effort will be futile and at last you will be without a degree. So you have to concentrate on time management in careful supervision of your supervisor. So these two reactions basically we use for designing of peptide, series of peptide, like amino group can be protected by making use of the BOC, tertiary oxynarpronide group. So, and reverse reaction, if you want to free this NH2 group, you can treat it with the TFA, trifluoroacetic acid, to get the free NH2 group again. Because once an amino acid has a two functional groups, COH and NH2, but one NH2 is required to couple with another COH group of another amino acid. So the free COH and another free NH2 is required to protect to go for a proper coupling. In addition to requirement of a coupling agent and a deprotecting agent. So one NH2 you will protect, one COH you will protect, one NH2 and CH2 will be freely available to couple in the presence of coupling agent. You will form a protected dipeptide, and then which end is required free functional group, that area you will deprotect to get the free group to go for the next coupling reaction. So similarly, you can see COH group can be protected by methyl esterification, and reverse reaction is feasible in 4-alkyl hydrolysis using lithium hydroxide. So you can free your COH group from the ester. This is the possible mechanism of BOC protection. Here you can see one H is protected by the BOC group, and this occurs through these 3 steps. You can go through the presentation later on. This is the possible mechanism for BOC deprotection, where you can easily find the CF3 group introduction, and this wall will remove to free the NH2 group. This is the possible BOC, which is shown in the blue BOC glycine. But if you go in the literature, you will find another amino group protecting agent like FMOC, CBZ. But if you compare, this is easily available and cheap, financial better. Similarly, you can see the coupling agent. DCC is the commonly used, but EDC and DIC are about more available in the literature, but these are relatively costly affairs. This is the mechanism for peptide coupling, how a highly insoluble dihycyclohexylurea product is formed at end, but it can be easily filtered through the coupling mechanism. But sometimes, it requires 0 degrees Celsius, 24 hours steering. The reactions are not so easy to maintain. Either we have to carefully observe the condition, or in some cases we have seen instead of dipeptide formation, octadolol forms, as shown here by this structure. Dipeptide was expected and heterocyclic ring resulted. So in order to avoid such situation, we can use the racemization suppressing agent like FOP, TMAP, and N-hydroxysuccinimide in our reaction along with the coupling agent. So we can avoid this situation. This is a possible mechanism through activating ester formation, how HOP can be used to avoid the octadolol formation and a dipeptide result. So this is what's gypsum D, which is a cyclic heptapeptide. I have shown the synthesis. Before a tripeptide unit defined by coupling of a dipeptide and amino acid unit, we form a tetrapeptide by coupling 2 dipeptide units. Now we have in hand a tripeptide and tetrapeptide. These two can be coupled together to form a linear heptapeptide, as shown in the slide here. So this is your heptapeptide. But remember, here both groups are protected. Now we require, suppose this COH group as free group for coupling. So we have to do the alkaline hydrolysis here. we require this NH2 group free for public. We have to treat it with the trifluoroacetic acid so that this NH2 and this COH group will be free and a peptide group bond will form here in formation of a heptapeptide. Finally, we can cyclize the product where it occurs through these 4 steps and we require standing of the reaction mixture for 1 week period in the presence of base. You can easily see the spectrum when you will cyclize the free amino and the free carboxyl bands will disappear and it will the CONH bands of peptide bond will appear. This is the PEMA spectrum where you can hypothetically break down your molecule on the paper. Here you can see the cleavage happen at furin glycine. So these particular bands appear due to this breakage. So likewise you can assign others. There may be other peaks which may be due to impurity. So how much pure your compound will be, that much you can avoid impurity peaks. So these are some of the antimicrobial peptides which we have synthesized in our laboratory from 2006 to 2011. These all are published reports. These are anthelmintic cyclic peptides. These are cytotoxic cyclic peptides. These 6 peptides I worked out when I moved in West Indies from 2015. We were able to synthesize and publish these reports. These are some of the projects currently I am working with. We are also designing prodrugs by synthesizing amino acid derivative of nacelles, and collaborations from faculties are welcome, those who are interested. Key takeaways. There are 2 types of project peptide-based product. Either you can make use of a pharmacognosy-based supervisor who is phytochemistry expert. You can go in C for the marine sponge isolation, marine mollusk. You can identify particular plants. Then you can develop column to isolate individual components, characterize them by the different different analytical techniques, and do the biological evaluation. So like that, a pharmacognosy or phytochemistry related project can be taken. It can be taken even at a pre-com research project level. MPOM is not there, but it is highly specific for MPOM pharmacognosy project. Secondly, if you are a pharmaceutical chemistry or medicinal chemistry student, you can design your own peptides. Like if suppose you have through the literature survey you have chosen a structure, you draw the structure on paper, dissociate into individual amino acid unit, reassemble by coupling technique in the clockwise manner to an identical peptide, compare the spectrum with the natural one, and you can compare the biological efficacy with the natural one. Further, if you want to do modification, you can utilize the technique like N-methylation. Here I have shown this column. You can N-methylate every peptide bond and you can derive a series of compounds. You can develop SAR. Second thing, you can employ the displacement strategy. Like this particular segment we can change. Okay, we know that dramamine is an established peptide antibiotic which is present in clinics and has the antimicrobial effect. You can go for literature survey of dramamine S and see which comorbidity dipeptide or tripeptide was common in all. That you can take from that paper, design in synthesize in a laboratory and insert in your design project. Obviously, there will be synergistic antimicrobial effect you can see. So like that you can modify the biological potential of our earlier existing compound. This is some of the scientific output for laboratory in form of patents, book chapters with Springer, Elsevier, articles in collaboration with different scientists all over the world. These are some of the foreign universities we are collaborating with. Indian university we are collaborating with, mostly my research scholars passed out from these universities. Instead of, in addition to teaching pharmaceutical and medicinal chemistry, we are highly involved in outreach programs in Trinidad. We go to different secondary schools, we go to different regional health authorities with students, and we educate them and support the WHO initiative on different diseases like cancer, diabetes, and we show them there are Ayurvedic plants around you. which can treat them you are not aware of. And we show some slides on which type of compound currently research is going on to treat that way. So like that we educate public, and I also urge here in India that staff can at least 6 monthly they can go for such visits in secondary school so that students can be educated from at the secondary level so that when they will come at college level they will give their input and we can get better scientists for future. Another thing I will urge out that we should convert ourselves from the academic researcher to the society beneficial researcher. We are merely doing the project for the academic merit, for our degree, and then we are forgetting. We are in the educational institute and we are the crucial part of the healthcare team. We must do some societal work in addition to our academic job. So I ask how much time everybody have, they should go in society and educate them through their lectures. So these are some of the schools and regional health authorities we have visited in past. This is my research lab. Our colleagues involved in outreach and research. We have 50% black population there and 50% are training Indians, whose forefather went from UP, Bihar, but now they don't speak Hindi. They speak only English. English is the national language of Trinidad and Tobago. So these are some of my accomplishments as already explained by reading my CV. So I received some local society awards, faculty awards, and I was among 2% leading scientists. Professor Gaurav is also among us. He is continuously for 4 years. He is among the 2% scientists. So you are lucky we are among 2% scientists, 2 people in one conference you are getting, and you will be able to listen. So map-wise, here is India, and there is a small dot called Trinidad, where I am. It is a 22 to 24 hour flight journey from here. Trinidad is a twin island, Trinidad and Tobago, which has a population of 1.4 million, which has only one pharmacy school, where I went as director. There is one pharmacy school in the whole country, 60 seats. So we are providing 60 pharmacies to society, and they are mainly occupied as community pharmacists or they are opening a drugstore. They run the BSc pharmacy like our B pharmacy, 4-year course, which is mostly community oriented like our farm districts. So they have very less industry, they don't go in that sector. Trinidad is famous for doubles like our chole bhature, North Indian dish, so that is street food there. It is famous for carnival. In fact, they enjoy in the road shows, they organize different type of dances in cultural costumes to increase their cultural involvement. Then, famous for beautiful beaches, there is crystal clear green or bluish water is there. You can see the sand from your naked eye. You can see the fishes from your naked eye. So much clear water it is. And you can enjoy that while you come there. And it is our beautiful campus of University of West Indies, which is a regional university, not a local university of Trinidad and Tobago. Our main campus is in Jamaica. And second biggest campus is in Trinidad and Tobago, and we have more campus like 5-island campus and an open campus in Barbados and the Antigua and Barbuda. So that's all about my journey of peptide synthesis for 24 years. Literature survey regarding the peptide chemistry, how to take different type of pharmacology and the pharmaceutical chemistry related project. You can attach to the presentation. I am keeping it here, and you can take help of your supervisor in small. You can involve in small as well as the big project. It is not necessary you must be a PG student. At UG level also you can do. I can supervise from there, but you must have availability of all the chemicals here, so that you can be trained on. And for that you will plan few months early, so that when those are arranged, I can guide you and we will be able to publish the collaborative international paper. So that's all from my side. Thanks for listening. Thank you. Any questions?
Now this session is open for questions. Audience, you can please, if you have any doubt, you can get it clarified from the yes sir. Sir, I have a small question. So those sir has just given us in a very simple way. We know because he is my super senior in NETEC. It is not that easy to synthesize cyclic peptides or peptides. Okay, if the reaction goes, then we are tough in getting the yields. Even if you get the yield, then stability problems are there. So may I know if you have given us so many structures and you have also synthesized many compounds. Can you tell us about the stability of these cyclic peptides? Are they
they are weak bonds, may break in the acidic environment of the stomach, but entry coating is there but before that, see, I am an academic researcher. I am not thought of pharmaceutical technology point of view. My part is to design a peptide, to characterize it, and to biologically evaluate. Then I stop thinking. Now, in further collaboration, same compound, if a pharmacologist take, he can go for the toxicological study, and a pharmaceutics person can take it for the formulation study, where stability come into question. In terms of reactions, we try to utilize the green chemistry, we try to avoid the use of EMF, but these entry coating, like how with the normal synthetic molecule we are using, if you have to pass the molecule through the acidic environment, those are applicable here also. But with the big molecule challenges are there, like passing of triple B, blood-brain barrier. But still techniques are there to handle that. But I will depend on my expert pharmaceutics expert when the project will go on. I'm here. My section is pure medicinal chemistry, so I deal with that. If that problem comes there, they can end the project there and that product cannot be utilized. But nowadays I'm seeing in the literature a lot of reports are there and those common techniques are also applicable on peptides. And if problem is coming with the higher molecule, we can design a tetrapeptide instead of a octapeptide and we can resolve the BBB problem. And entry-coating and other techniques are available to carry it forward. But still, I'm not sure on that fact. You have seen in the foreign papers, we have 10 experts instead of 2. They are like that. If I am doing a collaborative project, I am synthesizing and I will develop a formulation, then a pharmaceutical technologist and pharmacologist I am taking to.
Yes.
So they take care of that thing. So our mind runs on synthetic aspect, their mind. So that's why combined team is there. So I think they can give more expertise also on this question. But my position, according to my knowledge, those techniques should be applicable. So I have never carried out forward such a project to the hospital. That's why I advise the student. I remain as an academic researcher. My projects were not fruitful for the society. Never went to that level. But I urge, if we think of the projects starting from the F1 level, then we can go in that way. For that, the main thing is, if when any college have all the branches, chemistry, physics, pharmacology, then they start phytochemistry. So I will start from a single project. A phytochemistry person will go in literature survey. They will go to either sea or they will go to plant. They will isolate a cyclic peptide there. That cyclic peptide they will publish. They will give to me. I have medicinal chemistry. I will take that structure. I will dissociate it and reassociate it through in clockwise manner by solution phase technique. I will develop SAR of two different N-methylation technique or dissolution strategy. Now, and I will characterize the molecule and biologically evaluate them. Now we have derivative. Then, a pharmacology person, that person should give the project, okay, take this compound and do the toxicological study. Now, if toxicological studies are positive, then a pharmaceutics person should get the same project for formulation development. But this thing is not happening. Everybody is doing their own project. And that's why we are nowhere. And in COVID situation, people, death happens like animals, like pharmacology experiments are going on. Because we are academic researchers. We can think and our thinking stops when it is published and then we resolve and we move next. So that is drawback. We even, okay, leaving India, Even Europe and America, they were claiming their research and their development of compound is very nice, but their people died more than us. In America, a lot of people died, and we were doing the research and clinical trials during the COVID condition. We were taking chloroquine, anti-malarial drug to treat the virus. So, is that so? I have synthesized a peptide which has anti-cytotoxic effect, and if any cancer treatment, I will give that. So, no, you are saying that for development of a drug to clinical phase, it requires years, and during COVID condition, within 3 months, all things went away. So, how this happened? So that means we were not ready for the situation. And if we will take that concept, I will blame our academic research desire, with limited desire responsible for that. We as an institution, see, we should divide ourselves into who are researchers, who are teachers. Both are noble lines. That does not mean who can teach good and do little research. He is also a good person. He can do education. But in that way, suppose the college is giving 1 lakh budget and dividing into 10,000. We should select 4% and we should give 1 lakh to them so that they can go for a better project. And other can concentrate on teaching. Don't blame them, you are not doing research. You are doing good teaching. They are also asset, they are also asset. But by maintaining this ratio towards research and fund availability, we can develop, we can extend our academic research to the clinical practice. And that may be helpful there. And we have some, if some of the alumni is at NIPER level, we attach with that some facility we can avail from there. It is not necessary we will be able to develop this facility here, but try to do some collaborations at NIPERs and higher institutes where such facilities are available and we can go for. So my basic question is, I am a medicinal chemist. I focus on that area and I depend on other expert advice to develop it further. During synthesis, we characterize the compound and I not found any stability or those because we are using low temperature, 0 degrees temperature steering, and we are making use of freeze conditions. So I have not encountered that. Only it was respiration which could shown by use of respiration. So that is my input on your. Thank you.
Thank you, sir. Anybody just want to ask a question? Right, sir. We will end up this section. It's great pleasure to have Daya sir, who has much contributed to the synthetic chemistry. So nowadays we find less people doing synthetic chemistry. So we are fortunate to have you, sir. Thank you, sir. That was a wonderful nice highlight set of the research. Thank you very much. Now I hand over the mic to the partner.
Hereby scientific session 2 starts. I request Dr. Mohan Kumar sir, Principal Nirmala College of Pharmacy, Kadapa, be the chairperson for session 2 and co-chair Dr. S. Munir sir to present a brief profile of Dr. Gaurav Gupta sir.
Good morning, everyone. Myself, Dr. Mohan Kumar Uppala, the Professor and Principal, Nirmala College of Pharmacy, Kadapa. It's my privilege and honor to invite Dr. Gaurav Gupta, Adjunct Research Professor, Adman University, Ajman, UAE, for the second session. Now, I request Dr. S. Munir, Santaram College of Pharmacy, to introduce Gaurav Gupta to the audience. Thank you. It's really my privilege to give a brief about Dr. Gaurav Gupta sir, who is an esteemed pharmacologist and researcher recognized for his significant contribution to the field of molecular pharmacology neuropharmacology, and cancer biology. With over 13 years of academic and research experience across national and international institutions, he has established himself as a leading scientist in pharmaceutical sciences. Dr. Gaurav Gupta sir's scholarly impact is reflected in his extensive body of work, comprising more than 700 research articles in peer-reviewed international journals, collectively contributing to an impressive cumulative impact factor of 5,000. His scholarly achievements are further underscored by his Global Scholarship Index of 64 and ITEL Index of 397 and over 19,300 citations. Acknowledged globally for his research excellence, he has been consistently listed in the prestigious world ranking of top 2% scientists database compiled by Stanford University from 2020 to 2024. His recent endeavors has attracted significant funding, including Malaysian ringgit of 20,500 during his tenure at International Malaysian University, Malaysia, and 3 lakh INR in research grants from Association of Pharmacy Professionals in India. So beyond his extensive research contribution, Dr. Gaurav Gupta sir has demonstrated expertise in academic publishing, serving as an editor for several influential books, including Lung Cancer and Environmental Toxicants, elsewhere, gut microbiomes and environmental toxicants, terminal cancers, and symbiotics prejo, targeting epigenetics and inflammatory lung diseases, microbiome and inflammatory lung diseases, and medicinal plants in inflammatory lung diseases. His academic excellence has been recognized through numerous prestigious awards such as Young Scientist Award in the year 2019 at APP Annual Conference, the Innovative Researcher Award from the Association of Pharmacy Professionals in the year 2017, and multiple international research scholarships from the University of Newcastle, Australia, and additionally, he has actively contributed as an invited speaker at numerous global conferences addressing advancements in drug discovery, nanotechnology, and AI in pharmaceutical sciences. His research skills span a wide spectrum, including molecular biology techniques, real-time PCR, cell culture studies, pharmacological evaluation, and microbiological assays. So through his outstanding research, academic mentorship, and contributions to the pharmaceutical sciences, Dr. Gaurav Gupta sir continues to make a profound impact in his field, shaping the future of pharmacology and therapeutic innovation. Now I request Dr. Gaurav Gupta sir to take the session. Thank you.
A very good afternoon to all of you. Dear colleagues, dear students, first of all, I would like to thank Shantiram College of Pharmacy and Association of Pharmacy Professionals for organizing a wonderful conference on innovations in drug design, development, analysis, and patient care, synergizing science and practice. Innovation. If we talk about innovation, whether it is pharmacy or any industry like aviation industries, banking industries, IT industries, everywhere. Nowadays, there is a one term we are discussing, that is AI, artificial intelligence. Everywhere, in all the sectors, we are discussing only this one. So, if you see this theme of this conference, innovation, so in an upcoming era, like after 5 years, like 10 years, there is an era of artificial intelligence. If you are going to further do your research as a researcher scholar in a master or in a PhD, if you see your career, everywhere you will see the role of artificial intelligence. Lot of softwares, lot of technologies, lot of courses has already started, which are correlating your subject, your research field with the artificial intelligence. So the main outcome or the main conclusion is that if you are familiar, if you become familiar with the artificial intelligence, if you start learning to use artificial intelligence in your research studies, then you can easily correlate and you can easily get the job in the future. Otherwise, there is a big challenge for the new upcoming generations to get the job without failure of artificial intelligence. So this is the best time to learn about the artificial intelligence. What are the different softwares are available? how you can correlate those softwares in your research studies, how you can make your synopsis and your research with the correlation of artificial intelligence. Then only you can survive into the market. Otherwise, that is a big challenge. So in my talk, we'll see how this artificial intelligence is playing a role in your day-to-day life. What are the applications of this artificial intelligence? What is the need of today's era to use the artificial intelligence? What are the challenges we are facing currently and what the challenges we will face in the future if you are using artificial intelligence in all the sectors. That we will see in this presentation. So in this presentation, we'll see what is artificial intelligence, application, what are the needs of this artificial intelligence, applications and challenges that we will see. First is, what is artificial intelligence? It is a technology where those technologies are using a computer or the machineries, inserting a various type of data. The machineries, they are learning a new experiences on the basis of previous data and giving a decisions. Analyzing a data and giving a decisions. Those decisions are same like our human intelligence. How we are intelligent, how we are taking a decisions. In same way, our machineries are also taking a decisions on the basis of previous inserting data. That is called the artificial intelligence. Simple. How we are thinking, same machines are also giving the decision in the same way. That is artificial intelligence. So, a human brain, they can be think in the 360 around of area in all the sector, in all the way. In such a way, the machineries are also thinking. We human beings, we are inserting a data. So these machineries, they are accepting a data in a particular format, in a particular language that is called the algorithmic language. So in the form of algorithm, we are inserting a various type of the information into the machineries, and machineries are giving a or taking the decision, same like human brains, that is a artificial intelligence. Now we'll see some local or the examples which we are seeing in our day-to-day life. We all are using the mobile. Some of having using the Android mobile, some are using the iPhones. We having a various type of chatbots in our mobile. For Android, we are using the Alexa, we are using the Google chatbot. For the iPhone, we are using the Siri chatbot. So what is the basic use of this chatbot? Instead of typing, when you are giving the command to the chatbot, any type of command, you are getting the response from the mobile of the system. While you want to listen some news updates or the music or any type of information, you are listening those type of the reply from the chatbot. That is the best example of AI in our day-to-day life. Second example is the navigation apps. Nowadays we all are using the navigation, various type of the navigation apps while we are driving. Best example is Google Maps and Waze. So what these apps are doing, they are using the AI-based technologies and suggesting us the best short way so that we can easily reach to our destination in a very short period of time without any traffic. Again, it is making our life easy and more comfortable by using this type of AI-based technologies. Next example is social media. We all are now on a social media. We have all made our profile on the social media, either it is Instagram or Facebook or any type of social media are there, where we are updating all the information, our personal information, our name, where we are working, where we have done the education, all the information we are filling. So these AI-based technologies, they are helping us to find out our old friends as well as the current friends to make it increase our connectivity. So these type of software, AI-based technologies, they are making us more and more socialized so that we can be in contact with our known persons. Online shopping. We all are using the various type of websites for the online shopping, either it is Amazon or either it is Flipkart. So what is the AI technology using in these shopping sites? If anytime you are searching any particular products, next time these AI-based technologies, they are giving you a number of the list of the different type of the brands of the same product. So on the basis of the reviews, on the basis of the star value, you can easily decide which product or which brand product is best for you. So it can save your time and it is providing you the best quality of the product for you. Healthcare sector. In a healthcare sector, there is a lot of developments has done with the help of AI in the health sector, and this is the most emerging area for the pharmaceutical students also, that you can also search the new ideas how you can apply the AI in your research studies, so that you can get a good idea of development of the AI in the healthcare sector. So the best example of the AI in the health sector are our digital watch. We all are using nowadays the digital wearable watch. So this watch can help to maintain your health related data. How much calories you are burning, how much sleep cycle you are maintaining, what is your oxygen consumption capacity, your blood pressure, your glucose level, everything you can maintain with through your wearable device without discussion or without visiting to the clinic or the hospital. So this is the best example of AI in the healthcare sector. Further, we will discuss more about this one. Banking sectors. Nowadays, we all are having the saving accounts in the banking sector. So, banking sectors also using this AI to avoid any type of the fraud. They avoid any type of the cyber fraud, as well as they are with the help of AI. They are always suggesting you to invest your money in a best to best policies, so that you can increase your wealth. That is the main use of AI to improve your quality of life, to make your life easy. Next example is the smart home devices. Today, in most of the homes, if you see the new apartments, the builders, they are inserting everything is connecting, all the appliances smartly, which are connecting with the Alexa. So most of the home, if you see now, there is an Alexa in the home. You just give the command to the Alexa. Alexa can control your music system of your home. Alexa can control the lighting system of your home. Alexa can control the temperature of your home. It can control the security of your home. So everything is now controlled by the AI-based technologies. Entertainment. We all are using the OTT channels nowadays for the entertainment, for watching the movies, either it is Netflix, either it is Amazon Prime, various type of OTT channels are there. So what you are doing, what the AI is doing there, what are the particular movies you want to see, any particular interest of your movies, like if you like the sci-fi movies. So you have to just see one movie, next time they will give you the list of the same correlated movies, so that it is making you that easy to find out the interest of your movies. So these are the various type of the example you can see day to day in your life, how AI has already entered in your life, how this AI is making your life easy and comfortable. So now the question is like that, what is the need of AI in today's life? We are the human being. We are the most intelligent creature on the earth. Nowadays, we don't want to work physical. We want to work smartly. So for the smartly means automatic system. We want to convert each and every technique into the automatic system. So AI is the best example or the best technology which will convert every system into the automatic system. That is the best example of best need of requirement for the AI-based technologies. Data analysis. Data analysis means to maintain the record of anything. Either it is a record of bank, either it is a record of your healthcare system in the hospitals. So all the data analysis, earlier it was done by the human beings, like if we talk about 5 years before, it was maintained by the human beings, and there was a chances of error in the maintaining the data. And immediately if you ask any questions related to your data with the person who is maintaining the data, if you ask any questions for them to reply on your data, they have to take around 7 days to the 1 month to maintain your reply of your questions related to the data. But nowadays, thanks to the AI, within a fraction of seconds, whatever questions you can ask related to your data, it will give you the reply, and it will give you the exact answer of your data without any error. That is the best example. That's why we require the AI-based technology. Personalizations. Personalizations means you can check and discuss anything with the AI on your personal way. If you go for any banking site nowadays, if you go for any website nowadays, they are giving you the special personal chat box where you can ask any query related to the particular issue It is available for 24 hours and you can discuss any issue. Like in the banking sector also, if you do any bank, it will give the personal chatbot options are there. On the chatbot you can ask any questions related to your banking and they will reply you. And those chatbots are available for 24 hours. So that is an example of personalization. You should not wait for the daytime that is the customer care will can only contact you in the daytime. Now the site has overall customer care and the personal chatbots are available, which is provided by each and every company and you can discuss any type of your queries and issues for 24 hours. Like that, innovations, lot of chances of innovations are already going on. Lot of options of innovations are available right now for the AI, for the students. So these are the, again, one reason, improve decision making, improve safety, cost reduction. These are the various type of the requirements are there for the society for which we require the artificial intelligence. Next is how artificial intelligence is the future of pharma. Now we'll see how these artificial intelligences are playing a role in the future, in the pharma currently, and what are the future roles, what could be changes we can see in the future by this artificial intelligence. So the current drug discovery process too lengthy and too expensive. What do you mean by drug discovery process? Anyone? Any third year or before fourth year B.Pharm students or master students? What do you mean by drug discovery? What are the different phases of drug discovery? It's very easy. Anyone? Drug discovery. Drug discovery, a discovery of new drug. New drug means a new molecule. New molecule means you have to synthesize a new molecule into the laboratory and bring that molecule into the market. That is, a whole process is called the drug discovery. To synthesize a new molecule into the laboratory and bring that molecule into the market, that is called the drug discovery process. This complete process usually taking a 15 years of time, 15 years of time by the pharmaceutical companies. And usually it is taking a billions and billions of dollars of investment for discovering one single molecule. So what are the different phases in the molecule? First is discovery of the new molecule. Then you have to go for the preclinical trials where we have to do the trials on the animals, finding out the lethal dose and effective dose of the molecule. Then we have to go for the clinical trials. Various 4 phases are there. We have to go step by step all this process. So this complete process taking the 15 years of time and billions dollars of investment by the pharmaceutical companies. So it is a huge process, requiring a huge amount of money. So it's very challenging role for the pharmaceutical company. And after investing of that much time and that much of money, it is not confirmed that finally that molecule will be approved by the FDA or not. Because out of 100, only 10 molecules usually getting the final approval to launch into the market. Otherwise, 90% of molecules are going waste. So you can now imagine how much amount of money is invested by the pharmaceutical companies in drug discovery and how much amount they are wasting if they are not getting final approval to launch their drug into the market. But nowadays, thanks to the artificial intelligence, we having a nowadays lot of screening-based software that is called the computer-based drug design software. That is called the computer-based drug design software. Examples are Autodoc software, Discovery Studio, various type of studios are there where you can easily bind the molecule with the protein target of the disease, particular disease. You can easily see those reactions on the computer screen and check before starting of any research whether that particular molecule is being finding a affection with a particular protein or not, or it may produce any type of therapeutic efficiency or not. So these type of analysis you can easily do before starting of any type of research. So you can save your 15 years of time. If you do this study on the basis of artificial intelligence, then whatever the study we used to do in the 15 years, we can easily reduce and we can do the complete study within the 5 years of time. So we can save the 10 years of time as well as we can save a multi-million, billions and millions of amount also in discovering the new molecule. So like that, artificial intelligence has changed the complete research and development field of the pharmaceutical industry. So industry is currently said to spend well over $1 billion per drug. So you can see now industry, pharmaceutical industries, they are spending, earlier they were spending a billions and billions dollar of amount as well as the billions, the time, 15 years of time to discovering the one molecule. But now with the help of artificial intelligence, they have reduced the time period within 5-year period of time, and within a very less amount of the drug, the value, they can discover the new drug and can launch into the market. Now we'll see the various type of the applications where the artificial intelligence we are using in the pharmaceutical sector. The first sector is the research and development, R&D. Each and every pharmaceutical company they have here how R&D, research and development. Major of the pharmaceutical industries now they have already started using the artificial intelligence in their R&D. First is the drug discovery. Drug discovery just now we have already discussed that earlier it was taking a period of time, $1 billion of amount of investment they required, but nowadays with the help of artificial intelligence, within a very less period of time, they can discover and bring up new molecules. Virtual screening. Virtual screening means if you are going for the MRI scanning, if you are going for the CT scan, if you are going for the bone study, nowadays we are using the virtual screening AI-based technology, which can screen your all the database, all the of your X-ray, of your CT scan, of your MRI scan, and they can give you the better outcome result and better study as compared to the earlier. Predictive analytics. Personalized medicines. Personalized medicines. Nowadays, a gene sequencing technique is available into the market. Gene sequencing technique. In the gene sequencing technique, AI-based software will study your genes. We know each and every person having the different genetic structure in the DNA. So AI-based technology, they will study your completely gene-based study on the basis of your genetic structure. They can give you the prediction of your future happening diseases, whether the person can be happen with the cancer or any type of the severe diseases. On the basis of your genetic structure, they can give you the better decision or better outcome, whether in the future you are prone for any particular type of disease or not. On the basis of that, they can suggest you to change your diet plan. They can suggest you a better therapeutic options for avoiding those type of diseases. That is called the personalized medications. Then drug repurposing. Repurposing means anyone repurposing. Repurposing, reusing. Whatever the drugs are available in the market, example paracetamol. What is the use of paracetamol? For fever. For fever we are using the paracetamol. But nowadays pharmaceutical companies with the help of AI, they are trying to finding out the another therapeutic uses of the drugs which are already existing into the market. That is called the drug repurposing. It is the another research field for the students. If you want to go for the further research in your PhD or in your further research, you can select any existing market drug and try to find out any extra therapeutic uses. These all are possible with the help of the AI-based technology or AI-based computer-aided drug design software. Apart from this one, clinical trial optimizations, drug safety, adverse event predictions, image analysis, these are the various type of the applications of where the AI are using in the research and developments. So these are the major pharmaceutical companies which are currently using this AI-based technology in their research and development. Pfizer, Merck, what they are doing? They are trying to do the drug and drug proteins interactions they are doing in their lab and finding out the better outcome and better research analytics of the particular using of the drugs. So Pfizer, Merck, Novartis, Johnson & Johnson, GlaxoSmithKline, these are the major pharmaceutical companies which are using the artificial intelligence in their research and developments. Next is the drug development. Drug development, we have already discussed about the drug development. A drug development, that is a drug discovery, to bring the one molecule from the laboratory to the market, taking the 15 years of time and the billions of the dollars of the expenses. But nowadays, with the help of AI, the pharmaceutical companies, they have reduced the time of the drug discovery. Instead of 15 years, now they are taking only 5 years. Instead of billions and billions of dollars of investment, now they are in the few thousand of dollars. They are completing their new drug discovery process using the help of AI. Diagnosis. In the clinical sectors, in the various type of the diagnostical sectors, whether it's a X-ray, whether it's a body scanning, whether it's a CT scanning, whether it's a histopathological studies of any of your tissue, any of your cells, nowadays AI playing a significant role. They can give you the better image, they can give you the better outcome, they can give you the better interpretation of the your studies as compared to the earlier. A clinician as a human being, they can't able to study the clearly about those type of the images. What the AI is now doing, they are doing the better than the clinicians. So these are the various examples of using of this AI in the diagnosis, image analysis, clinical decision support, differential diagnosis, risk predictions, telemedicine, personalized medicine, and as a diagnosis during the emergencies. A telemedicine during the COVID, there was a restriction to meet person to persons. We know about the COVID timing. So on that time, the clinicians, we always meet the clinician through the telemedicine, where on the screen you can see the clinicians, and from the clinic only the clinician can meet you through your phone with the help of the telescreening. On the telescreening, you can discuss with the clinician, discuss about your disease, and the clinician can give you the better diagnosis report or about your therapeutic medication. So these are the various types of example, and the best example is the robotic surgery. If you go in any type of a major hospital nowadays, you can see the advertisement of the robotic surgery. All the major surgeries in the hospitals are now doing by the robotic surgery. So any type of the error during the surgery can be avoided with the help of AI-based robotic surgery or AI-based technology. Disease prevention. In the disease prevention, all the pharmaceutical companies, they are only investing their money in the research and development for the particular type of the diseases which are very common in the society. Example, diabetes. Diabetes is the most popular disease in our India. So all the major pharmaceutical companies, they are investing their money in the research and development for introducing or for bringing the new diabetic drugs into the market, so they can capture more and more number of patients and they can earn more and more amount of money. No any companies are investing their money in the rare or uncommon diseases like Alzheimer or Parkinson's or type 1 diabetes. So these type of diseases, there is very less number of patients are available to the society. So the pharmaceutical companies, they don't want to invest their money for the less number of patients. So nowadays, thanks to the AI-based technologies. So AI-based technologies, through the molecular docking studies, through the computer-aided drug design, within a very less amount of money, for a short period of time of the using by the scientists, we can easily discover the new treatment for the rare type of the diseases also with the help of AI. Epidemic predictions. If you heard in the COVID, there is a lot of AI-based softwares are available. In those software, you have to insert the geographical data of the particular region. You have to insert any type of the particular infection spread in the particular region. You have to insert the biological data of the persons of the particular region. So if you insert those type of information in the AI-based the software, you can easily find out the particular area, whether which area is now prone for the epidemic in the future upcoming any type of the infection or not. The best example of those software are the ProMed, Bluedot, Metabiota, HealthNet. These are the software which are helping us to find out the most epidemic area where the future any type of the infections can occur in the future. The best example of the software is the ProMed. ProMed was used during the COVID-19, where the scientists have inserted all the data and they find out the most epidemic area of the COVID-19 during the COVID-19. Remote monitoring. Nowadays, AI-based a lot of remote monitoring devices are available in the market. So you should not visit every time to the clinics. If you talk about it 10 years before, every time if we having a BP, if we having a sugar, if we having a fever, every time we have to go to the clinics, if we have to go to the hospitals, stand in a queue and wait for our time. So we are wasting a lot of time and energy and money also. But nowadays, lot of AI-based software devices are available. If you use those devices, You can avoid to visit the clinics for the minor diseases. You can avoid the hospital for the minor diseases, and you can easily maintain and check your health related data in your body. So the best example, your BP instruments. Everybody we know about this one. Digital wristwatch. Through the wristwatch, you can easily measure your all the data, burning calorie, burning and your energies, your oxygen consumption capacity, BP, sugar level, everything you are maintaining by this device. This is a new device. You can see this device that is calling the digital pills dispenser. This is a new device that is calling the digital pills dispenser. In elderly patients, all the Alzheimer patients who are having a short-term memory, they are not able to memorize about their dosage time. In the daytime, at what time they have to take the drug, in which dose they have to take the drug and which drug they have to take. So it's very difficult for them to maintain or to memorize about their drugs. So this is the device for them. So the device is connecting with the patient's mobile, and they are always sending an alarm to the patient that this is the time to take the medication, which dose, which color they have to take. Everything they are sending the alarm to the patient and helping the patient to make their life easy. This is one more new device, that is AI-powered insulin delivery system. Nowadays, the insulin pump is available in the market. That pump, there is a small chip comes with the pump chip. You have to insert on your stomach. Pump you can keep in your pocket, and this pump is always releasing the insulin in your body, and that will come work like an artificial insulin dispenser for your body. Okay. Along with this one more device is there. You can see on the arm there is a very small chip type of structure is there. That is called the CGM, continuous glucose monitoring device. That is a small chip like of structures are there that doctor will insert or will stick on your arm. It will give you 24/7 your glucose monitoring information. At what time your glucose level will be high, at what time your glucose level will be low. So through that information you can easily maintain your glucose level. But nowadays with the help of AI, this CGM device is connected with your insulin pump. Whenever your body is getting the high level of glucose, it is measuring by the chip, and that chip will send the information to your pump, and your pump will release the insulin as per the requirement of your body. So this is the best example to maintain the glucose level in your body with the help of this AI. Another example of this one is a non-invasive glucose monitoring devices. As we know now, currently, whenever we have to check our glucose level, every time we have to prick our finger with the needle. So sometimes it is painful. But nowadays, there is a device is available. There you have to just insert your finger without pricking. It will give you blood glucose information. Next, AI-powered retinal screening devices. When we are not able to maintain the glucose level in our body for a longer period of time, it will slowly start to damage your blood vessels, your vascular system. So first organ which is damaged, if you are not maintaining your glucose level, is your retina, your eyes. So AI has developed a device that is a AI-powered retinal screening-based devices. So instead of going to the ophthalmologist into the hospital, with the help of this device in your home, you can check the condition of your retina, whether it is perfect or not. Wearing sweat-based glucose monitoring. So this sweat-based glucose monitoring, small chips are available now with the help of AI. It will stick on your wrist and it can read your glucose level. So slowly, AI-based technologies and companies, what they are doing, they are transferring this chip into your digital wristwatch. So directly by wearing your wristwatch, you can easily maintain your glucose level. You can measure your glucose level. So these are the various type of smart AI-based devices are there, and a lot of opportunities are still available into the market. If you go and do the research, you can find out the better result and better outcome. Manufacturing. In the manufacturing industries, human beings are replacing by the AI-based technology. technologies, AI-based technologies, what they are doing, they are improving the quality of the product, they are reducing the waste material of the product, they are increasing the amount of the product. So for this purpose, now all the major pharmaceutical companies, they are using the AI-based software, AI-based technology. Now let's see the marketing. In the marketing also, what is the current situation or what are the past situation of the marketing? As a pharmacist, you can do the job of medical rep also. You have to go to the hospital, visit or meet with your doctor, show your product, and then you can write that to the advertisement. But nowadays, major pharmaceutical companies like Sanofi, Pfizer, Novartis, what they are doing, they are scanning the prescriptions of the patients. Lot of e-pharmacies are available in the website. As a patient, when you are uploading your prescription on the e-pharmacy, those prescriptions are also screened by the various pharmaceutical companies, and they are observing which patients are using the competitive product of their company. Suppose if we talk about diabetic medications, the diabetic major companies, they are screening the various type of the prescriptions, finding out a particular target group of the patients, and they are only targeting those patients to show their advertisement. So like that, they are avoiding the whole population and they are specifically targeting the for their product to the particular group of the patients. So these are the major pharmaceutical companies, Sanofi, Pfizer, Novartis, which are using those type of the technologies in their marketing. Drug adherence and the doses. Drug adherence and the doses, as we have already discussed, that lot of softwares are available which are sending the alarm to the mobile of the patients, like which type of the medications they have to take, which color, in which dose, so that the patient can easily adhere with their drugs and with their doses. So they are making the patient's life very easy with the help of these AI-based technologies. Now, the most important thing, major challenges, especially those challenges are for you as students. You will face these all challenges in the future. First, job. For each and every sector, they are using the AI-based technologies. Through that, everything is now converting into the automatic system. There is no requirement of human beings. So where you will get the job? There is no requirement of human beings. So there is no requirement for you also. So for that one, you have to learn the AI-based technologies. You should be familiar with the AI-based software, AI-based courses. Then only you can survive into the market. If you bring the AI in your research, in your study, in your career, then only you can survive in the market. Otherwise, there is a very difficult challenge. It's challenging for you to get the job into the market. Responsibility and the accountability. If any error occurs into the AI-based software in any company, then who will be the responsible? There is no any single person is behind the AI-based software. A teamwork is there. So for any error occur into the AI software, nobody will take the responsibility or the accountability. Data protection, there is the risk of data protection or data breaching also into the market. You have seen the many times, you have read in the media, social media, that lot of a credit card customers information has leaked into the dark website or into the media. Why it is happening? Due to the data breaching of those things. So who will be the responsible? And how can you find out? How can you catch those type of criminals? It is a challenge. Human rejections in all the sectors. By using these AI-based technologies, they are the rejection of the human beings. There is no use of human beings in any type of the sector, majorly after 10 or 15 years. Investment. To use the AI-based technologies in our business, in our industry, it is little bit expensive. So only a big companies, a big good companies, they can only use this AI-based technologies. For small companies, it is very difficult. That's why the small companies, they are not making their business nowadays, and only the big companies, they are surviving in the market. Emotional support. There is no emotional support by using the AI-based technologies. Future aspects, where we can see ourselves, where we can see AI-based technologies after 10 years, 15 years, 20 years, or 30 years. Human will not be allowed to drive. We can see after 10-20 years a driverless car into the market. Even Tesla has already started their trials in Dubai about the driverless cars. So after 5 or 10 years, you can see in the market a driverless car. There is no requirement of drive. AI will drive your car. You will have an AI doctor. Up to 2050, each and every single person will get their personal doctor. AI will become your personal doctor. It will scan your genetic structure. On the basis of your genetic structure, it can suggest you your diet chart, your medications, your daily life maintenance, and whatever the future happening, the chances are there that also predicted by the AI. So up to year 2050, each and every person will have their own doctor, that is AI-based doctor. Your boss will be a boss. If you go any company for the job, to whom we have to first meet, that is a human resource department, HR department. Okay? In future, you won't see any HR department in industry. Both will be available. It will screen your CV, whether your CV is potential to do the job in the particular industry or not. So like that, AI-based board system will be there in all the companies who can hire you on the basis of your performance, who can fire you on the basis if you are not performing well. So everything will be controlling of your job by the board system in future. Smart homes will be common. All the homes will be converted into the smart home device by the converting into the smart home system. Your light system, your music, your temperature, your stress level of your body, even if you are using the washing machine, how much amount of water required in the washing machine, according to your clothes, whether your cloth is silk or it is a woolen or whatever type of your cloth is there. So for the particular cloth, what type of water is required, that is also controlling and maintaining by the AI-based software. Everything is controlled by the AI. Next example, your home appliance refrigerator. You all are using the fridge. What are the expiry? If any product in our fridge is expired or not, that will be also giving the information by the AI. What we are lacking in our fridge, what the fruits we have already finished in our fridge, whatever the content has finished in our fridge. Everything, the list, everything is maintained by the AI, and they are giving us the list for allowed to maintain all the quality and everything by the AI. So all the homes will convert in such a way into the AI based, that is called the smart home devices. There will be a robotic criminals. In future, you can see the robotic criminal. The best example is the iRobot, the Will Smith movie in the Hollywood. If you see that movie, you can see how the robot is converting into the criminal mind and how they are doing the criminal activities in the society. Robots will beat us in the sports. In the sports also you can see the robot as a athlete. They will perform various type of the sports activities. And I think even nowadays also even the university activities you can see the remote car running competitions. So that is also best example of this robotic sports activities. Then news will be written by the humans, not written by the humans. All the writing jobs will be performed by the AI-based software. Even nowadays also, if you are writing any assignment, if you are writing any of your research synopsis, if you are writing your thesis, then also you are taking the help of various software for improving your English language, for correcting your typographical error, for improving your grammatical errors, for everything we are using the software. So in future, all the writing contents will be doing by the AI-based software. So these are the role of AI in our day-to-day life as well as in our pharmaceutical industries. So it's a challenging for you. If you can use the AI-based software in your career, then only you will get the job. Otherwise, it's very risky, it's challenging to survive into the market. So I would like to acknowledge my this talk to Association of Pharmacy Professional Society as well as to the Shantiram College of Pharmacy for organizing this wonderful conference. These are my some research collaborators along with whom I am doing the various research. These are of my few published books which I published in Springer, Elsewhere, Care and Francis. Thanks a lot.
So Thank you very much, sir. Are there any questions from the audience?
A warm welcome, myself, Dr. B. Krishna, from Senior College of Pharmaceutical Sciences, studying for public. My query is, how can AI improve patient outcomes and reduce healthcare costs?
Patient outcomes nowadays, especially if you talk about clinical trials. In clinical trials, for maintaining the database, we are using the AI-based software in various type of the clinical trials. For the patient care also, like if you talk in clinical trials, earlier we were using the thousands of patients for doing the clinical trials of the particular product. Okay. So what are the negative effects of those clinical trials? You have to hire some thousands of persons for particular drug trials. Okay. You have to make a contract with them. If in the clinical trials any adverse events happens like vomiting, diarrhea, any type of adverse event, patient should not get any type of treatment until that trial will be finished. So there may be a lot of painful situations was there earlier with the patients while using those type of the trial. But now with the help of AI-based technologies, we are reducing those number of patients. Instead of 1,000, we have just bringing it 100 patients. And with the previous data, using of those data, AI taking the decision of what the outcome of, and they are modifying the outcome of the clinical trials with the 100 patients. So like that, we are improving the patient care development and the patient care.
Sir, as you said, knowing about the AI is very important to sustain job. So can you suggest us any online courses for that?
As a student, for you, in a master, in a PhD, you can learn computer-aided drug design software. These softwares are paid as well as freely also available. Like lot of paid software is Schrodinger software is the best software in the computer-aided design. It is paid. Free software, Autodoc software is there, Discovery software is there. So you can learn those software. There is a lot of courses are available on the YouTube as well as time to time. Various type of the workshops are also conducted by the various research centers, a government research centers. There you can learn these technologies, and this AI-based computer-aided design you can apply in any branch of your pharmacy. If you are selecting the pharmacology, there also you can, in particular the pharmacology, we are going for the animal studies or the cell line studies. That also you can coordinate with the computer design. If you are going for the pharmaceutics, in the formulation, that also you can easily coordinate. If you go into the pharmacognosy, you can easily coordinate with the phytochemical chemistry. So like that you can easily correlate with this. This is the best way to learn, and you can apply this in your career. There is a lot of requirement in there for the computer-aided drug design software, especially in the market as well as for the pharmaceutical companies.
Thank you, sir.
Still anyone from the delegates?
Good afternoon, sir. Sir, as you said that importance of AI in the future, so along with that, as a pharmacist and scientist, so what skills we need in future to work along with AI?
If you talk about pharmacists, in future, as a pharmacist, our major job is to compounding the drug. If you see the past history, where the pharmacist himself, they are making the medication in the stock and they are compounding. That is the main job of the pharmacist. Okay, in future you can see the 3D technology based formulation. In the pharmacy shop, you can keep your 3D based tablet machine on the basis of patient. If the patient is small children, okay, children don't like a taste of tablet because the taste is not good for the children. Children like on the basis of children's requirement, you can make the shape to the tablet, any toy shape tablet. You can give the color to the tablet. You can give the taste to the tablet on the basis of requirement of the patient, and you can make formulate your own medications or formulation of the medication in your shop. That is called the 3D based technology formulation. And it is already started in the market in the India. Soon they will introduce in the India. So that is the best way of more pharmacists into the AI based technology. Apart from this one, not a lot of softwares are available AI based. If you go for the any type, not even the lot of courses are also available nowadays.
Incoming call
Like,
from Mirage
go
SRC.
for the course
Identify
era
by
website.
true caller.
There is a one website that is a course era. This course era website, they are showing a number of courses related to the AI in the pharmaceutical sector, and those courses are introduced by the various type of the international universities, and those courses are freely available. So you can access those courses and you can learn how this AI is introducing into the pharmaceutical sector, and you can generate your own ideas. Anybody else? Any question?
Anyone?
Okay, thanks a lot. We wish you good luck for your career.
Thank you very much for having such a wonderful session. So all the delegates you can leave for the lunch. And after the session, till up to 3 p.m. you will have a e-portion and oral session will continue. And session 3 will start